So let me recap the last class, the lecture 1. We are still in the chapter 1, the introduction to computer software. This was the lecture 1. So in the lecture 1, we actually covered some very basic stuff. We started with what are the computer components, what is a computer software, what are the types of software we have, what is the operating system, and what are the main parts and functions of operating system, and what are the categories of operating system. So these are the basic 5 topics we just covered in the lecture 1. So if I go one by one, computer system components. Computer has 4 components: a hardware, a operating system, an application programs, and the users. Then what is a computer software? A software is actually refers to the program that executes on the computer. It actually helps the computer to step by step to finish some task, because we know computer actually cannot make their own decision. So software actually helps computer. It actually shows computer with how to actually solve an individual problem. The solve can be simple as adding two numbers, or it can be complicated like copying a picture, modifying a picture, and so on. Then the next, there are types of software. We have 2 types of software: application and system software. The difference between these 2 types of software is that we use application software for specialized reason or for entertainment purpose, or maybe to study, okay, etc, etc. And we use system software to actually maintain the system. In system we mean our system resources and other management issues. And then we have the system software. It actually has 4 types of program in the system software. So first we have operating system, we have utilities, we have device drivers, we have language translators. What is operating system? It coordinates computer resources. And then utilities program. Utilities program is specified tasks related to managing computer resources. And then we have device drivers, allow particular input or output device to communicate with the rest of the computer system. And then we have language translators that converts the programming instruction into a language the computer understand. That means from Java to machine code, to PHP to machine code, to Python to machine code, and so on. Then the operating system actually performs 3 type of function. Okay, it actually manage computer resources, it provide a user interface, and also runs other applications, that means other softwares. The main part of the operating system is kernel. It's a program that actually runs all the time. Then we have device drivers, we have user interface, and system utilities like antivirus, backup software, disk cleaners, and so on. And then we have the detailed function of an operating system. Managing our resources means you can at the same time manage memory, processing, storage, and other devices. Then you can monitor system performance, schedule tasks, provide security, and start up the computer. Provide user interface. There are 2 types of interface. It can be character-based interface, or it can be graphical user interface. And running application means running all types of programs. It may be a foreground. For example, the PDF is running in the front end or foreground, and in the back end there are other softwares or programs that's running in the back end. Then these are the common operating system functions: so management of the memory, process management, storage management, device management, monitor performance, job scheduling, user interface, and security. And now we comes to the categories. So there are actually 3 types of categories. Remember, all of this operating system actually does the same thing. Okay, their functions are basically same, but depending on the devices, we actually change the algorithm or how to approach a certain problem. For example, first one is embedded operating system that we use in smartphone, cable TV, turner boxes, and so on. Then we have the network operating system, that where we handle multiple servers, Unix, and so on. And then we have a standalone operating system, that is the desktop or the one that you are using and I am using. And we have finally, we have Windows, we have Mac, and we have Unix and Linux. And each of these operating system has some advantages, has some disadvantages. Okay, depends on which operating system you're using. In Bangladesh, most familiar is the Windows. It's familiar not because it has advantage, because it's, it's easily, you whenever you actually try to set up a new Windows, it's easily available. So sometimes some softwares we actually use them not because they are good, because they're actually available most. Now, next point, that we have some mobile operating system as well: BlackBerry, iPhone, Android, Symbian, Windows Phone. So this is all about the lecture one. Again, what we did, we actually focused on this 5. Computer has 4 components. What is a computer? Software that helps computer to do something. What are the types of software? 2 types: application and system software. What are the operating system? It has 3 type of function: help to manage resources, graphical user interface, and run program. It
Hello,
has,
sir.
yes.
Sir, Rifti Rahman is trying to enter the Zoom, sir.
Tell him to change his name. Okay, use a proper name. There.
Okay, sir.
Okay, now the parts and functions, it has 7 to 8 different functions: main, process management, memory management, and so on. And there are 3 types of categories of operating system. So that sums up our chapter 1. Now, anyone have any question regarding chapter 1? I guess no, right? That's easy. So now we go to the lecture 2. So before going to the lecture 2, let's see what are the content of this lecture. We'll try again, we'll resume the introduction of the computer system. Okay, top level view of computer system, that how actually computer system work. And then we'll get to know that processor, registers, instruction execution, how operating system actually runs a program, and interrupts. So all these are very actually exciting topics. So I will go one by one. So first of all, the easy one. Okay, introduction. So what is actually a computer system? As you can see from the definition, a computer system is one that is able to take a set of inputs, process them, and create a set of output. This is done by combination of hardware and software. So that means if a machine can take set of inputs, process those inputs, and create a set of outputs, that is a computer system. And we actually use a combination of hardware and software for that. Now, depending on what you are trying to do, the requirements of hardware and software might change. For a normal computer, we have mouse and keyboard for input, and for the output, we have the monitor. For in classes that we take in IOBT, for input, we also have keyboard and mouse, but for the output, we also have a projector. Okay, so depends on the scenarios and availability of resources, the input and output devices may change, but the computer system is whatever that takes input provides you with an output. That is a computer system. So if you have a smartwatch, that will be also a computer system. Now, what is an operating system? An operating system is a program that acts as the interface between the user and the computer hardware and controls the execution of all kinds of programs. Now, before I have told you that operating system is actually helps to manage control resources, right? So those resources are memory, hard uh, memory, then we have different processes, and then we have input output devices. So basically, whenever you have a hardware, that means whenever you type something using your keyboard, or you click something in your screen using your mouse, okay, these are hardwares. These instructions, okay, these are sent to your computer, and the operating system, it actually communicates and facilitates between the other softwares and your hardware. So if you look at the picture here, this is an abstract view. Abstract means it's not in detailed. So we have different users. All of them are using different types of software. Okay, they can be using system software or application software. all these softwares, they actually cannot communicate with the hardware directly. They have to communicate through the operating system. So if they want to take an input using keyboard, they first ask the operating system that I want to take an input from the keyboard. Then what it does, it takes the input and sends it to the system software. Same goes for RAM or CPU. Whatever resources you have, okay, whether it's a processing power or the storage and so on, it has to go through operating system. There is one exception though. We'll discuss the exception end of the class. So what are the basic elements? At the top level view, okay, we have processor that controls the operation of the computer and performs data processing functions. We have the main memory that stores the data and the programs, also known as primary memory, is volatile in nature. We have input output modules. We have the move data between computer and external environment. It consists of secondary memory devices, communication equipment, and so on. We have system bus that provides communication among processors and main memory and input output modules. So before going to the top view, again, we have four main structural elements. First one is the processor. That is actually the brain of the computer. Most of here in Bangladesh, we use Intel i3, i5, i7, these processors, and some of us also use AMD. So processor actually what it does, okay, it's actually very small device that actually does a lot of calculation. In the next class, I will actually show you a video of how actually processor work. So it will make you, you'll be able to understand more clearly. But in short, processor, what it does, it actually performs a lot of calculations. Okay. Then we have the main memory. We know there are two types of memory.
Sir,
Yes.
I have a question about processor.
Yes.
So you said there's two type of processor mainly. One is Intel Core i5-719 DC, and other
i5,
is
i7, this
I.
not
Yeah.
mainly two type in Bangladesh.
Yes, sir. And other is AMD, sir.
Yes.
The between two processor, which is the best, sir?
Among these two, it actually depends what you want to do with your computer. If you want it for the normal user, okay, that if you just want to play games, just watch movies, then Intel is fine. AMD's, they are trying to actually develop a specialized processor. Okay, so it actually depends what you are trying to do with your computer. Whereas for normal use, Intel is so far the best.
And sir, if I want to do some special work with using this processor,
then I guess it depends on what you want to do. You can go for AMD.
Okay, sir.
So now let's go back here. So we have the main memory. We know there are different types of memory. One is the hard disk that we all know. Okay, so hard disk, and then we have RAM, we have ROM. Okay, and then input output modules, and system bus is actually like a roads or actually like a connection wires. Using those, computer actually send data from one part of the computer to another part of the computer. So let's just look at the picture. So we have actually first, as you can see, we have actually four parts here. First one is the CPU. Then we have the input output module. That means the keyboard, the mouse, and whatever. And then we have the main memory. And then this is the fourth part, the system bus. So our whole computer actually divided into these three parts: CPU, input output module, main memory, and all of these are connected by the fourth part, that is the system bus. So let's first focus on the system bus. What it does, it actually is like a wire that actually helps to transfer data or instructions from one part of the computer to another part. For example, from CPU to main memory, if you want to send some data or instructions, okay, instruction means if you want to send a program, so just you will use the system bus. Okay, they are just like the local bus, okay, but inside the computer they transfer data from one part of the another part. Okay, now let's focus on the next easy part, input output module. Okay, as you can see, there's a word here that is called buffer. So I will discuss what is buffer. Input output modules are actually helps to take input from different devices. It can be a mouse, it can be a keyboard, it can be a joystick, okay, it can be a scanner. And what is a buffer? Buffer is actually whenever you take an input, that input is being sent from the input output module to the CPU using the bus. But sometimes the bus might be busy, okay, it might be doing other work. So what happens in that case, whenever suppose you're writing something on your keyboard, okay, suppose you have typed your name, but at that same time the system bus is actually busy, it's actually doing some other task. So what it does, it cannot send the data from input output module to the CPU. So buffer is actually a very short memory, okay, or small amount of memory that can temporarily save some data. That means your name, suppose your name is Sakib, so if you type Sakib, and if for some reason, there are a lot of reasons that system bus can be busy. So if for some reason the system bus is full or busy, this buffer will actually save the data for a small amount of time. So that's how actually this input output module works. So we are done with this too. Then let's come to the main memory. So in the main memory, that is, you can take the hard disk, or we can also use hard disk called with secondary memory. So RAM is basically, whenever we say about the main memory, we actually mean RAM, random access memory. Why RAM? Why not ROM? So basically main memory is something that from where computer, okay, actually takes instructions, that means program and data, and execute them. Now the problem is that RAM and ROM, they are actually fast, but the hard disk that we have, okay, is actually not that fast. Suppose if you have a hard disk of 1 terabyte, that is 1000 of 24 GB. First of all, it is called secondary memory, okay, where everything is stored. Okay, everything that you see from starting your computer to different movies, running different softwares, everything is stored there. So whenever suppose you have started your computer, and if you want to listen to a music, or you want to browse internet, so you open music player, let's assume that VLC player, and also at the same time you run the Google Chrome. So whenever you run these softwares will actually fetched from the secondary memory and be loaded to the RAM. Now why we are actually loading the software to the RAM? Because we know that CPU actually works very fast, and secondary memory, that means your hard disk, is actually not that very fast. Now why hard disk is slow, we'll discuss it, okay, in the upcoming chapters, but for now we'll just know the hard disk is slow, okay. So it's slow, we need to actually transfer data very fast among memory to CPU, so we use RAM is actually way faster than the hard disk. So we store the programs that we are using in the RAM, at the same time the data related to the program. So if I talk about in this class, you are using the Zoom platform, so the Zoom is actually loaded into my second main memory, that is RAM. At the same time, okay, I'm using PDF reader, that is also loaded into my RAM, and other data, the operating system lecture 2, it's also loaded into the main memory. So I have Zoom, I have PDF reader, I have the data of lecture 2, and so on. Okay, and then finally we have the main part, CPU, central processing unit, the brain of the computer. Okay, in the CPU there are some terminologies we'll discuss in the upcoming slides. For now, what is PC? PC is program counter, as you can see from the slide. Then we have IR, IR is instruction register. MAR, MAR is memory address register. MBR, memory buffer register. IOAR is input output address register, and IOBR is input output buffer register. So let me go one by one. What is a program counter? Okay, so each of these programs in the main memory have actually a serial, so that computer can understand which one to go first and which one to go second. So this is called a program counter or the instructions counter. So computer actually keep tracks that I am executing program number 1. After finishing the program number 1, I will go to the program number 2. After finishing 2, I'll go to program number 3. So computer actually keeps track, and to keep track, it use this register. Okay, PC, program counter. Then we have IR, instruction register. So suppose I'm executing instruction number 1, okay, or program number 1. This program from this main memory will be using the system bus, will be loaded into this one, IR, so that CPU can actually execute that instruction. Then we have memory address register. What it does, it actually contains the memory of address of different memories, or at the same time it actually holds which memory I should go for. For example, if I told you that my house number is 5, okay, this actually, if you ask me your address and I say my house number is 5, you'll ask, sir, where? Because it can be Uttara, sector 6, road 6, then 5. It can be Uttara, sector 10, road 6, then house number 5, and so on. So memory address registers and buffer registers, they actually help us to pinpoint the location of the instruction, which instruction I'm executing and how. And then we have the input output address registers and buffer register. So they basically keep track which input devices I have, mouse or keyboard, and what are their addresses, the port numbers, and so on. Now, as you have seen, I have continuously told about register, register, register. So we'll see what is actually a register. Processor registers, what is actually register, how it works, and why we use register. So first thing first, the definition. A processor includes a set of registers that provide memory that is faster and smaller than main memory. So that means our registers are actually a memory that is faster than the main memory and at the same time smaller in amount. Try to remember one thing, that in computer, okay, there are different types of memory. Okay, they have different type of sizes. The higher the size, the lower the speed. That means if I talk about the highest memory in your computer, that is obviously the hard disk. It is from 80 GB to 1024 GB to 2000 GB or 5 GB, okay, or 5 terabytes, sorry. So this memory, they are actually huge in size, but they're actually very slow in terms of speed. So central processing unit can actually execute billions of instructions. Billion means, 100 crore. So it can execute 100 crore instructions in 1 second. Okay, that means if you ask it to add 1,000 numbers in, and it can do it within 1 second. Okay, or if I ask you to add billion numbers, it can do it within 1 second. So you see, CPU actually is very fast, and to work with the CPU properly, to keep the balance, we actually need fast memory. So then we have the main memory that is faster than the secondary memory, but still there are some issues, and that's why you use other types of memory called register, latch, cache memory. You may be familiar with the term cache. So this is the idea. Okay, so register is kind of memory that is smaller than the main memory and faster. Registers normally measured by the number of bits they can hold. So if a register can hold 8 bit, it's called 8-bit register. It can hold 32 bit, it's called 32-bit register, not byte. Okay, remember, from 8 bit we get 1 byte. So if it can hold 8 bit, we call it 8-bit register. If it holds 32 bit, we call it 32-bit registers. Now, what is the function of the processor? It actually exchanges the data with the memory. Is it the only task? Obviously no, it has many other tasks, but it is one of the tasks. So there are two types of registers. One is user visible and is control and status registers. What is the difference between these two? User visible registers, you can actually access, you can manipulate the data, okay, or you can actually request to access the data. Control and status registers, they're actually beyond you. They are automatically controlled by the computer for their own use. Now, we'll talk about user visible registers. What are the user visible registers are? Before going to the definition, let's first go through the name. General purpose registers, data register, address register, condition code registers. From the name you can guess, general purpose register can store the general thing like data and address. Okay, it can hold variable and temporary result. So that means it is suitable for every general task. Data registers, can hold numeric values such as integer and some architectures, floating point values, characters, small bit arrays, and other data. That means data bit registers actually store data. That's it. Address registers, as you can see from the name, holds addresses. So it can be a index register, segment pointer, or stack pointer. So what is the index or segment pointer? We'll come back to that. And stack pointer we'll discuss in the upcoming classes. And finally, we have conditional code registers. They are also referred as flag. So their use are to set bit by the CPU hardware for the result of an operation. So what is a flag? Suppose one operation is done and you want your computer to know that I am done with this one. Then we use a flag operator. That means this is done. So these are the condition codes. Now, let's go into the details. Index registers, values added and offset from some address. Index addressing is a common mode of addressing that involves adding an index to base value to get the effective address. So let me explain this one, okay? So let's assume that in computer, okay, we have memory addresses like this one, 1101, 1102. So let's assume the addresses are like this. Okay, so these are the smallest addresses, but the problem is a computer memory is huge. This amount of small address doesn't actually help. So the addresses are like this. And so on, okay. We use hexadecimal to make things easier. But here, as you see, the problem is this is a huge address. It's very difficult to remember. Now, just like your college student ID, so it's actually almost 7-digit student ID. But sometimes what we do, instead of using student ID, we actually use the serial number because it's easier to remember, easier to track. Okay. Again, another point is, suppose your ID is 134442. Then your friend's ID is 134443. So instead of calling you 134442, I can just call you hey 42, hey 43. Okay, because I know that 1344 is common to everyone's name. Same task is done by the index registers. Okay, so a value is added as an offset. Okay, so that you can just call it a simple name. So that means if your ID is 134442, I will just call you 42, and this part will be added later because I know that next one is 43 and so on. So we'll actually see some examples and some maths related to index registers. So if you don't understand or don't get the full picture, don't worry. We have a lot of times. Segment pointer, again with segment addresses, memory is divided into segments which are variable length block of words. So again, we actually don't know what is a segment. We'll discuss it in the upcoming chapters. And then we have the stack pointers, store the address of the last program request in a stack. So suppose you're working with back-to-back two programs, so it always keep tracks which one is the last program you have used for request. So to sum things up, I know there's a lot of values here. So we have, this is the top view of our computer. In the top view, we actually have 4 parts: a CPU, a main memory, and an input-output module. Our main memory is connected by a system bus. In input-output module, we have different devices, mouse, keyboard, and also buffer, which actually store the data for a small amount of time before sending it to the CPU or the main memory. A main memory holds instructions and data, but here the instruction or the programs are not all the programs. It only holds the program that you are using at a certain moment. And then we have the CPU. It has different registers to perform the executions or the instructions properly. We have program counter that actually counts which program you're executing next. We have IR that actually holds the instructions. We have 4 different registers to actually hold the addresses. And then we have the execution unit, the most important part that actually executes the instructions. So this is the top level view. And then we have registers. Registers are actually a small amount of memory that is actually faster than the main memory. We call them by their memory size. So it's can be 8-bit or the 32-bit. There are two types of registers, user visible and the control status. So user visible registers have different functions. One is used general purpose for storing data and address. Another is used only for data. Another one is used for address. So there are different types of address registers: index, segment, stack pointer. And then we have the conditional code registers that is used as flag. So these are the four types of user visible register. That is the one we are done. So user visible registers are four type. One actually general, another one actually holds data, another one actually holds addresses. So general, G, data, addresses, and then the last one is control codes. Okay. And then we have the control and status registers. So control and status registers are again, they're different types. So first one is memory address register, specifies the address in the memory for the next read and write. Then we have memory buffer register, input output address registers, buffer register, program counter, instruction register, and then this two. Now here, as you can see, the first six, we have already read them here. You see, these are the control registers: memory address register, buffer registers, input address registers, buffer register, program counter, and instruction registers. So all these are actually from CPU. So CPU actually use the control and status registers. And there's two more here, as you can see, special purpose register. So what they do, they actually usually include the program counter and the status registers, and the program counter and status register might be combined into a program status word, PSW. So again, one more time, there are a lot of words that you actually don't understand right now, like what is actually a program status word. So eventually we'll discuss them. Okay, the lesson I want you to take from this first 8 slide, let me cover, yes, the first 8 slide. That again, if I go back to the beginning, that what is the computer system? It is a combination of software and hardware that can actually take input from the user, process that input, and show some output. So your calculator is also a computer system because it takes input from you, it actually processes the and does the calculation and shows you the output. Then we want to understand what is the operating system. It actually acts as the interface between all the software applications and the CPU, RAM, and other hardwares. In the basic elements of computer, we have this 4-part: CPU, system bus, main memory, and input output module. Each of them have their own separate task. So after that, we go to the registers, okay, because the register is very common here. And there are two types of register. First one is user visible, that can be read or written by the machine instructions. That means you can actually read them or write them, okay. So there are 4 types of user visible register. Just remember their name and what are their functions is actually easy to remember. Then we have different types of control and status registers that actually controlled by the CPU itself, okay. And again, here we have some jargons like program status words. So if you don't understand, don't worry, just try to remember so far what we have learned. Then the last topic for today, okay. So let me just skip this here. So instruction execution. In your computer, whenever you run a program, each program you already know, you have actually developed your own projects, so you know how hard it is. Okay, once you first want to develop a project, it's actually not that easy. The code becomes huge. Normally, whenever you are actually solving a problem in the class, the code is 100 lines maybe. But whenever you are trying to develop a project, the code becomes actually almost 1,000 lines. Depends on what type of project you are doing. It will at least, it will be minimum of 500 lines. So suppose you have developed a project. Your project name is what name should we call it? Let's call it a shopping management system. Using your software, I can actually buy something. Okay. Now, whenever I actually run your program, all the program, the code of 500 line. Okay, let's assume your code has 500 line, will be actually loaded into the memory. Now, the problem is, even though the whole 500 line is loaded into the memory, or I can, instead of calling it 500 lines, let me call it 500 instructions. So in my main memory, that is, let's assume this is RAM. In my RAM, I have a program that is my shopping management system, and it's the number of instruction is 500. So I have to execute the 500 lines one by one to run the program smoothly. So this is called instruction execution. So how actually it happens? First, we start with selecting the program, which one we want to run. So my program is shopping management system. Then what the computer does, okay, it actually fetch the next instruction. That means if there are 500 instruction, it starts with obviously one, right? So it will fetch the instruction number one. It execute the instruction number one. Then after that, it checks whether there is any more instruction or not. If there are more instruction, it goes again. And if there is not, it actually stops the program. So then in my program, we have line number 2 and line number 3 and so on. So again, it will go to the execute stage. And from execute stage, it will again go back to the fetch stage. Fetch stage means collecting next instruction. So it will first start with 1. It will execute 1. And then it will check whether there is any other instructions here or not. If there are not any other instruction, it will go to the second. Okay, it will fetch the second, it will execute the second, and just like that, it will go up to 500 lines. Now, there are obviously some catch here. Okay, for example, there might be a coordinating if-else condition. So if one of the instructions is fulfilled, your code might skip from line number 3 to line number 200. Okay, so this will not go into that details here. I hope that you understand on your own. So what is this called? This is called instruction execution by a processor. Okay, so each program consists of set of instructions stored in the memory. We actually, what we do, we fetch those instructions, we execute those instructions, and we wait for the next one. This is called an instruction cycle. And the processing required for a single instruction is also called instruction cycle. Then at a fundamental level, we have these 4 steps: fetch instruction, decode the instruction, execute the instruction, and repeat the instruction. So when I say decode the instruction, it actually has 2 meanings. Okay, so for normally decode means that translating your Java code to machine code. Okay, this is one kind of decode, because computer, if it want to execute a program, it only understands 0 and 1. So if you want to make sure that your program is executed very fast on your own, you have to make sure that it's decoded, it's not coded. Okay, so that we don't have to decode it. And then we have the execution cycle, and we keep repeating this one. So this is actually another view. So this is my main memory. This is the CPU. So this is the program. While 1, that means while the program condition is true, that means you are running the program, it will fetch instruction from the memory. This is our memory. Okay, so 1, 2, 3, 4. So from there, it will fetch instruction one by one. It will execute those instructions, and we will store the result. So that's where we will finish our today's class. Now, if you have any questions, you can ask now.